So, our last thing for complex numbers is division. Okay. For those of you that were in class, I kind of explained to you, you can't have a radical in the denominator, give you a whole historical perspective that you didn't care about, but, you know, makes me feel better. So what you need to do is you can't have I in the denominator because you can't have square roots in the denominator. I kind of explained that during class for whatever goofy reason. So what I want you to see is, well, I want you to think about is how can I make this the I in the denominator, into a whole number. So I'm just going to go through the whole procedure for this. So all I need to do is I know that I squared is equal to -1. So I can make this into an I squared. It can be a -1, and then I won't have that in there. So how do I make this into I squared? I actually multiply this by I over I. Now this is just a fancy form. This is just a very fancy one. Okay? So all I'm doing is I'm just multiplying by 1. So I can change my problem, and I don't have an I in the denominator. So I multiply across. 10 times I is 10I. 2I times I, well, there's 2I, so it's 2I squared. So we kind of do the same thing. You multiply, and then you same thing that we did with addition. You multiply, and then you replace all of your I squareds with -1. So I look at this after I do my multiplication. Anytime I see an I squared, I change that to -1, and then I simplify. So this is going to be 10I over -2. Okay? Now you could stop there, but you want to see, can each part be divided by my denominator? Does 2 go into 10? Yes, 2 goes into 10, -5 times. So this becomes -5, and we just have our i's. That's our final answer, is -5i. Okay? So we'll do number 14. Multiply again by I over I. The -9 is not a problem, leave it alone. Okay, multiply by top. This is going to be 4i. I multiply by bottom. I have -9i squared. Okay. Then, same thing that we do for everything is anytime I see an I squared, I rewrite it as -1. So this is 4i over 9. Can we simplify 4 over 9? No, it's as simple as possible. Don't write any decimals. Okay. 9 is not going to be 4 a nice number of times. So that's my final answer. 15, a little bit of a catch. Okay, I still do the same thing. My problem is still the denominator, so you don't ever multiply anything. Doesn't matter, you can even kind of look at the numerator. Okay, so I still multiplying by I over I. Okay, this case right here, just a little bit of distributive property. Okay, so I multiply the top. All right, so I do distributive property. That's going to be 28i minus 8 is fine, and then I times I is I squared over 4I squared. Guess what I do from here? Of course, I am going to replace I squared with -1. So I have 28I minus 8 times -1 over 4 times -1. So I have 28I plus 8 over -4. Now what you notice is I told you to ask yourself, does 4 go into 28? Does 4 go into 8? Yes. Okay, so you can divide each part. So what I end up with is -4 goes into 28, -7i times. -4 goes into 8, -2 times. Okay, so that can be your answer. If you want to write it properly, it should be -2 minus 7i. But I would actually accept either of these answers. Okay? And last but not least, I here and I here. This is -8i minus 2i squared. So you distributive property over 6i squared. -8i minus 2 times -1 over 6 times -1. -8i plus 2 over -6. I want you guys to take this. Okay, you might want to rewrite it, 2 minus 85 over negative 6. You can simplify it further, we'll get to that when we do polynomials, but this is all I want from you. So that is our